Assalamualaikum and hi. We are from Group 9 and we will be discussing about radius of investigation. In this tutorial video, we will elaborate more about the definition of the radius of investigation, the explanation on the graph of radius of investigation, uses of radius of investigation, and an example to solve so we can get a better understanding. Radius of investigation, or RI, represents how far the pressure disturbance has traveled into the reservoir. It created when disturbance such as change in rate occurs at a well. The distance is related to formation and walk-through properties such as porosity, permeability, and time elapsed.
Radius of investigation. It is important to understand the graph available related to this radius of investigation topic. Let's first understand this graph of pressure against radius. This graph shows that shut-in of the well occurs. Let us recap what is well shut-in. Well shut-in is an attempt to constrict the oil supply. As the oil flow is constricted, the flow rate of oil is zero, and the pressure from radius of boundary towards the radius of the well will be the initial pressure. Yahoo! Let's proceed to the second graph related to radius of investigation. This is another graph of pressure against radius that is very important to be learned. Carefully observe the graph. From the graph, we can see that there is no pressure value from the center towards the radius of the wellbore. Why is this happening? It is because the pressure changes inside the wellbore is very small. Therefore, it is neglected. Pressure starts to rise when the radius increases. The maximum pressure will be reached before the pressure stabilizes. The maximum pressure indicates the radius of investigation. The higher the pressure, the shorter the time taken to reach the radius of investigation. What can we conclude from the graph? It is very important to know that the pressure when the radius of investigation is detected. From the pressure value, we can determine time. Are you still with me? Hopefully the answer is a yes. This graph is similar like the previous graph, but with different pressure reading this time. When the pressure is high, the time taken to reach the radius of investigation is shorter, therefore less distance is traveled, resulting in small in radius value. Opposite things happen for the lower pressure. When the pressure is low, the time taken to reach the radius of investigation is longer, therefore more distance is traveled, results in high in radius value. To summarize this graph, pressure disturbance moves further as flow increase and reach the maximum pressure. It will then stabilize to the initial pressure. That's all about the graph related in understanding radius of investigation. Thank you.
The uses of radius of investigation. The uses of radius of investigation. First,
Estimate the drainage area.
second,
Explain the shape of pressure build-up or pressure drawdown curve.
and third.
To estimate time required to test to the desired depth in the formation. The first uses of radius of investigation is to estimate the
Drainage area.
how to estimate the drainage area. Drainage area can be found from the build-up pressure graph, with bottom hole pressure at the y-axis and log of time at the x-axis. As we can see from the build-up pressure graph, there is a constant slope. The constant slope represents the drainage area. Drainage area is the area where the pressure disturbance occurs, followed with the constant flow rate. The second uses of radius of investigation is to explain the shape of pressure build-up or pressure drawdown curve. As we can see from the graph, before the wellbore effects end, There is a difficulty to interpret the shape when the radius of investigation is in the zone of altered permeability, or also called as skin zone. At the end of the constant loop, the effects of low barrier begin, causes build-up curve changes its shape. This is because radius of investigation has reached the reservoir boundary or the reservoir heterogeneity.
The third uses of radius of investigation to estimate time required to test to the desired depth in the formation. Based on the radius of investigation equation, in order to estimate the time, we have to put the t to the left side of the equation. And from this equation, we will get the specific time of a specific radius which we input into the equation. The Ts in the equation means the time required for stabilization, whereby there is no pressure disturbance inside the reservoir. Ts will occur when the radius of investigation is equal to the radius of external, which is the boundary of the reservoir.
For example, we may want to sample reservoir properties at least 500 feet from a tested well. How long a test should be run? Is it 6 hours or 24 hours? No, not definitely, because it's either too short or too long. So we can use the radius of investigation, which use the means of estimating the length of time required to achieve stabilized flow. Let's see the case study. We wish to run a flow test of an exploratory well for sufficiently long to ensure that the well will drain a cylinder of more than 1000 feet radius. Given information of K equal to 100 mD, porosity, pressure, and mu. The solution is very easy, as we use the formula that has been given on the previous slides, which we consider that the radius of investigation equal to radius of wellbore. Only the difference is we use 2000 as a safety purpose, and then how we get the answer. Thank you.